Hello, everybody. I'm happy to talk about grid-free programming again. This is lecture 25. I will continue to talk about multicasting API. Last time, I introduced how to implement such API using primitive API and distributed knowledge. And I need to emphasize that even though it's easy, it's not so difficult to implement a new API with distributed primitives of it grid-free. We still need to have a design pattern. This is a convention in grid-free. So each API need to have a corresponding pattern that can be used by developers to save a lot of programming efforts. So what about the pattern for root clan? For example, root clan is one of the two important API for multicasting. Another one is the child clan. What about for this one? What about the pattern? Here you can see this language, this sentence. I think the pattern for the root clan is exactly the same as SRE, because when we implement SRE, what knowledge do we use? What technique do we use? The technique we use is SRE. What about the knowledge? We just use some distributed knowledge about multicasting. What is how do you implement your multicasting? How do you construct for multicasting? You need to construct one particular hierarchical structure. That's a tree. In our case, that's a tree-like structure. How to overcome the fault tolerance problem. So that's the distributed knowledge. This knowledge can also be regarded as the upper level application. And all those knowledge usually can be encapsulated. Users of such API, are not required to care about that. So we just provide simplified interfaces. That is what API means, right? So we just encapsulate the underlying, the internal knowledge, and then provide a simplified interface. So you can, because of that, because only SRE is used, so the pattern in grid-free, if one particular distributed API is used, then the pattern is identical, is exactly the same as the pattern for such API. That's one principle in grid-free. We have seen such principle when we program the CS client and we program with the program with the peer, right? So because of that, when we program peer is a combination of the client server. So its design pattern is straightforward aggregation of the API for client, the design pattern for client, the design pattern for the server. So for the multicasting API, root client is, although it's consume a lot of effort for us to program the code, because you see a lot of the code is many codes need to be programmed for its knowledge, for its upper level application description for multicasting. However, if the API is originated from distributed primitive, original one of the distributed primitives, then its design pattern is exactly the same as the API. For this case, only one API is selected, is SRE, so its pattern is identical to that of SRE. But you can see that there is a difference between the pattern of SRE and the pattern for root clan. The difference is that root clan has a new method. This method is useful to collect all the responses from the children within the cluster. So we have a concept called random point (RP). So that's a difference because we have new concept (RP). So such method, such design pattern is different, a little bit different from SRE because SRE has no such concept. But that's easy to be understood. We use RE to implement the reading, right? Here you can see here, reading is required to be performed with SRE. SRE just used to send a notification. It's an eventer. E represent the word eventer. Eventer can only be used to send a notification. If so, usually it's impossible for us to perform reading action. However, because we have already implement the readable point, so even though we use remote eventer, we can still perform reading action. So that's why there's such a difference. But I think that in this case, you can regard that difference as exposure, the RP of remoter. I think when you program TCP network programming, and I think on the application level, on the communication level, on the network level, there must be a similar implementation, similar to that of RP, but we did not see it. It encapsulated or it hidden this RP. So you do not need to care about that. But I think in my case, at least right now, RP is visible. But actually, or maybe in the future, I will take a look whether we can encapsulate or hidden. You can hide RP from developers, but that means because I need to use SRE to perform reading action, so that's a difference. However, that's another solution to network programming using my own techniques. So the RP should be used. So well, that's why some difference occurs on this API. So, but I don't think that's the difference. That's a big difference between the design patterns of SRE and the design patterns for root clan. We can still regard as the SRE. You can still think that the pattern of root clan is exactly the same as SRE. Okay, so it's easy to be understood. Okay, the child clan. The child clan is easy, right? Child clan has no. Let us open my Eclipse. Let us take a look at the code. Child clan exactly the same because in child clan, when we implement child clan, there's no such difference, right? You can see this is a child clan. This is a child clan. This is child clan. There are no such concept, no technique, no readable point is required for child clan. So this API notify, read, synchronous notify, synchronous read, all the method is the exact same. The pattern, at least the pattern, is exactly the same as synchronous remote eventer. Let me open this code. Okay, this is the code. Actually, the notification is almost exactly the same. Notify, notify. Okay. The one difference because they had a port, but I don't think from the design patterns point of view, they are almost the same. They are exactly the same. CS client, we can open this one. Notify, synchronous notify, asynchronous notify, read, yeah, okay. All that's exactly the same. The pattern from pattern point of view, they are the same. Okay, so next, what should I do? Next, I will show you how to program with root clan and child clan to establish a multicasting framework. I will next I will show this example to you. I will establish a multicasting framework based on root clan and child clan, so you can maybe in the next class I will program online using such a framework and programming one particular application. I have no idea what I want to do in the next class. I just think I just want to do as what I have done. I just got an idea just 1 minute before such class and start programming immediately. That can prove the quality of my sister. That can prove my sister is highly patent. So just the user can just follow the design pattern and design their application conveniently and rapidly. Okay, so this time you can see as we talked before, multicasting framework is very important. We use multicasting framework in large scale of system. So in such a case, when we run such a system, you can see there are a lot of nodes. There are a lot of terminals should be opened so we can run our system with a lot of process, with a lot of multiple distributed nodes. Actually, if you have sufficient number of computers, if you have sufficient computer resources, such a skill is unlimited, it's infinite. Okay, let us take a look at the code. You can find the code in this way. First, multicast, right? Multicast, this one. Oh, one thing I also need to mention is that let us take a look at the root clan again, because my system still be improved. So just a couple of hours ago, I made some changes to this code to simplify the programming if you want to use it. Here, last time we talked about this one, right? This code, using this API, this method, user can broadcast this request to all the children within a hierarchical structure and get response from those structure, right? From all the children. However, you can see this is a multicast response. However, when we implement such a system, when we implement a upper level application, this code is you can see it's a parent. It's a parent. It's a this code should be derived. We should extend such code because it's too abstract. We'll extend the code to implement subclass to implement one specific message, broadcast message for us. So in this case, we need to convert this generics to the specific list. In that list contains our own subclass that extend multicast response. How to do that? In this case, I implement another method. Using this method, this conversion can be performed by another API I implemented. So you do not need to consider how this. If you are interested, you can take a look. But I do not want to discuss about this low-level issue because it's just a Java programming. We just convert the list, the list of the parent class to a list of a subclass. So the user do not need to care about that. If you invoke this method to perform multicasting read, you have to do that yourself. But I think in the previous classes, in the old version, user have to do that yourself by developers. But I don't think it's good enough. So I changed the method to this way. Okay, and the same as this method. So if multiple responses should be converted, the list should be converted, and I always implement such a method so you can. Usually I suggest you to use this one, so you are not required to do this conversion. So this is a better way to, if you want to perform reading within a hierarchical structure, right? Okay, so I just add those methods. So all the multicasting reading are upgraded because I always upgrade the system. If I found something is not designed properly. Okay, you can see, right? All the methods, all the reading methods are changed. But if you are interested, you still can use this method, but I don't think it's a convenient way to perform multicasting reading. Okay, so let us take now. Okay, that's just I want to emphasize for this time. So now let us open the application. You can find this application of the framework from according to the package name. You can see here, this is the package, this is a root, this is a root implementation, and then this is child, this is the child, root, child, this is the message, this is a client. Why do we need to have a client? That means the client sends the information to the root, and the root multicast such information to all of its children. That's why I need to have a client. The root is just like a server, a special server. It's waiting for incoming message. After this message is received from the client, and then the message is broadcasted, anycasted or unicast. So that's why I design a client. But you think the client is very easy to be designed. You just use the techniques we talked before. Okay, so let us take a look. Start from here. Start from the root. Okay. I think you need to pay much attention to the design pattern. In addition to the API, you can see here the code. You must see such pattern before. So see such code structures many times. This is a starting point. Let us open this one. Okay, the API called root peer. here there is a peer is used because this is root. You can see, you can regard this system as a extended version for for the n tier structure or 3-tier structure. In this case, the frontier is still the client. The frontier is still the client. This is the frontier. The middle tier is the root peer. In the 3-tier architecture, the peer is used as a business logic or the middle tier, so that any information or any message received by it can be forwarded to its to the 3rd tier. But in this case, the 3rd tier is more complicated. The tier is the child, not unique node of the server. So there are a lot of children. All of the children can work together at the 3rd tier, so that such a computing system can have a lot of computing resources, have sufficient computing resources to deal with a high volume data, high volume task, right? That's why I want to use multicasting, because maybe in the near future we need to establish a cluster, right? I need to design, organize all of the computing resource together to deal with heavy load computing task. So at that time, we need to the multicasting is very important. We can further organize those children or those computers together with our API, and we can establish large-scale distributed system. Okay, this is the peer. So we have ever implemented such similar code before, because it's a middle tier, right? Middle tier. One difference is here. We have a root master. I think there is a root master. What is root master? Let us take a look at this one. This one you can, it's better for us to make a comparison between the code structure or design pattern. We can take a look at the three-tier architecture. Three-tier architecture is here, right? Let us take a look at the coordinator. This is, we discussed this code in previous classes. Here, the peer, that's the same, right? Peer is same. Peer, the pattern for peer is the straightforward aggregation of the server and the client. Here, we still need to aggregate something. In this case, this is the notify query. This is the not eventer. This is the reader, right? So this is the code here is just like server. So peer is the pattern of peer is a straightforward aggregation of the client and the server. And for this case, because we need to perform multicasting, so the peer should be started as a server first, and then what else? We need to have a root multicaster. Root multicaster you can regard regard as routing master as a upper level application. And so here for this case, usually we put upper level application here, right? This is for dispose. Usually we need to collect all the applications here. And because this case is simple, so maybe we can show another example. The chatting, I'm not sure whether you remember it or not, because they code it too simple. There are no upper level application code. However, for this one, for the chatting, there's some code about upper level application. Chat peer. Chat peer, okay. Chat peer is also simple, okay. It doesn't matter, but I think you must remember here in the old design for chatting, because the peer is also contains the design pattern of because this case is simple, so there are no application level implementation. So let us take a look at another one. I want to explain this concept clearly. This chatting, okay. For this case, there are some application level stuff here. So for that, you can, because of multicasting, right? Multicasting can be regarded as a application based on the P2P network. So because we talked about that before, right? Okay, this one can be understood, can be regarded as an upper level application. So here, for this case, for the chatting, we just dispose, right? For this case, we just need to install. That's the same thing, right? That's the same thing. Okay, next. We need to perform initializing here. Yeah, okay. For this case, the root master is start from here. Root master is start from here. Okay, and then we do some initialization here, right? Some initialization, broadcast some message to the system. Okay, so this case, the overall architecture or overall structure is the coding. The code structure is no change. Actually, no anything is updated. At least from the design patterns point of view, no anything is updated from the design patterns of view. Okay, so this code is easy to be understood. Okay, next, let us take a look at root. I think this one is difficult. Let us open this one first. That is easy to be understood. Okay, that's the same thing, right? For this server dispatcher is old code. However, for this code, the only difference is that it contains a lot of messages. Yeah, only the message are updates. Only the message is are increased, but the code structure is exactly the same. The code structure is exactly the same. Code structure or design patterns does not change. What about this notification? All this notification and request are sent from the client. Only this one is not sent from. These two messages are sent from the administrator. This one called shutdown. This shut down the children. This one is used to shut down the server. However, all the code here code structure are similar to each other. You can see maybe, yeah, there are a lot of code here. It looks a lot of redundant code. Can we simplify the coding? Yes, we can do that later. Okay, but before that, I want to just show you the code structure is exactly the same. Exactly the same. So I don't want to explain such code. I just want to tell you all the message sent from client, and then the data is broadcasted. After the message from the client is received, the data is broadcast by invoke the message of root master. Here, the same thing happen here. After the anycast notification is received, the anycast information message is sent to the client. This one is a unicast. After unicast notification is received, unicast notification is sent to the client. Okay, this is a request. Broadcast request. This code a little bit complete. You can see here, right? This broad read, this message I just mentioned this message. This is update. I just update this message a couple of hours ago. If no such message, you have to use this one. You can see here, right? This is the old code. If you do not invoke the code I just upgrade, you have to use the one I introduced last class in the last classes. This is old one. Because the old one, no conversion between the list of parent class to the list of subclass. You have made this conversion by you have to perform conversion by yourself. So the code looks not simple enough, right? The developer have to upper level developers have to implement such a method by themselves. The code looks not simple, so it's better for you to use this code. Then the code looks more simple, right? More simple. Just perform broad read. This method called broad read, and then the response is generated and returned to the client. Okay, we just remove those warnings. So this code looks more simple. And let us take a look at another one. This for anycast reading. Okay, the comment line are the old code, but this code looks simple, right? This code looks, oh, no, this one is not the one, and this one is, yeah. Maybe this one I forget change it. Okay, let us change it here immediately. This one is not changed timeline, so it's better for us to use the union rate. I'm not sure whether the code is implemented or not. Okay. So this code looks more simple, right? It's better. It's a better code. Okay. We don't need to perform the conversion by ourselves. So this code, because I just upgraded the code a couple of hours ago, so I forget upgrade this line. Let's take a look at this one, the anycast. This is just oh, this is unicast. The one is I just show you is oh, this one should be upgrade again. I forget to do that. Okay, let us do that again. Okay. Okay, let me say this one should be any read, right? Okay, that's great. Okay, so this code is easy to be understood. Next, we need to pay much attention to this one. Okay, this is the singleton, right? This is a singleton structure. We have this is the kernel of the singleton is the root clan. We see such code eventually. Using this code, when you program this code, you can see the code structure. This is a notify, right? This is a synchronous notify. This is a unicast notify. This is a broadcast read. This is I just made some changes here. This one is all the way to implement the broadcast read. I hope you can use this code, this implementation. This in different from the one. This one. This is for this one. This is the parent response. However, this is the specific responses. Because in different applications, there are specific, there are subclass we need to use as a message. So hello world broadcast response should implement, should extend, should derive multicast response. So we need to usually in specific application we have to extend this message. So here we just we need to do some conversion. However, if you want to do that yourself, it's fine, but I think it's better you use this method. Okay, this is the response. That's a better way for us to implement multicasting reading. The same thing happened here, right? This is anycast. This is all the way, all solution. The parent list, the list of that contain the parent message are returned. It's not good enough. This is unicast read. Okay, I think the server side is just one difference is here. We need to expose the random point. We just need to expose the random point here. Random point here. We just need to expose this one. Okay, and then why do we need to expose this message? Because here you can see this. There are three thread. These three we start from here, broadcast, right? And why do we need to implement this code? This code. This one is called response. Do you see it? This code. This 6 message are sent from the client. I just forget to mention this 3 one. This 3 one is different. These 3 ones are different. This 3 message, this is response. This is response. Right? This is unicast response. This is anycast response. This is broadcast response. These 3 messages are sent from the children. I think so. A lot of all the children need to send their after they get response. We need to all the responses should send to the unique server. So the server, the unique readable point, readable point. The root is the unique readable point. So the server after it got a response, it need to save it to the readable point. Then after all the message are received, then if the sufficient message received, the reading will request a reading action based on the hierarchical structure, based on the multicasting can be finished. So you need all the message should be saved to the renderer point. That's why we need to expose the renderer point. That's why we need to expose the renderer point, because this renderer point should be used by those threads, because those threads need to collect all the responses from the children. So this is a root side. This is the root side application. I think the application is, if you use the root client to program, because the code structure does not change. Although we start to program a complex system, more complex system than this one, right? This one is based on, for example, this one. Although we start to program a complex system, this system, you can see here, this is the MNCS. This system only is based on client server. This one is not scalable. Only unique server is computer resources that can be shared by multiple clients. So this system is not scalable. This system is centralized. This system is contains very limited computer resources. However, you can see the code. I'm not sure you agree or not, but I think you should agree. You should agree with me, because although the two different systems, this is a multicasting based system. This one is very simple, right? It's only programmed with no any advanced API is available. This is a very traditional, a very typical client server based system. However, for this case, we start programming a large scale system. Infinity number of computers are included in such a system. However, you can see here the code structure is exactly the same. There are no any difference in terms of code structure. That's very important, right? So it saves us a lot of efforts. There another it's one benefit we can get from such a programming paradigm. Another advantage is that in the near future, because the code structure is almost the same, even though we program different system, then I think in the near future we can, if we want to design a programming language, all the code can be generated by the computers. We do not need to program by ourselves. You can see if we program based on such a framework, I always copy, paste, and replace something. I always perform the repeatable action. Copy, paste, and replace. So this behavior, if all this behavior are repeatable, and if all the code are similar to each other or exactly the same in terms of code design patterns, why can't we generate the code using some algorithm, using one particular designed compiler? We can do that. right? Okay, so this is one important uh, fun, one important feature of grade 3. Okay, next we start from here. This is the children. Children should be easy because children is just perform forwarding. Each children, if the children get the notification from its parent, it then forward this message to its direct connected children. Okay, let us take a look at the code. Okay, the code is same. Code structure is same. Open this one. Okay, this is peer. Okay, this is the peer, and then one difference is this there is a singleton called child master. The child master can be regarded as an upper level application based on peer-to-peer framework. And then some this pattern belongs to the peer, right? Belongs to peer. Some attribute need to be exposed by that can be used in the later cases. I will show you later. Okay. Notify root. This is a client, right? This is a client pattern. This is a client pattern of the peer, because the peer need to interact with the root. So I implement such method. So after the peer generate response, this one is used only in the case when the peer, then the child generate a response and need to send this response to the root. When is the peer need to do that? When the child need to do that, this method is invoked. This method is identical to is one part of the client code, right? So I don't think any difficulty here for you to program. What about this one? One attribute need to be set here. This is a root address. This one can also be understood as one attribute, one of the code on the upper level application, because each peer need to know the root IP address. That's very important. If the child does not know the IP address of the root, then it's impossible for it to send a response to the root. Then the reading action based on multicasting cannot be performed. So this code, all of this code can be understood as a upper level application code. The overall structure of the code does not change. Okay, let us take a look at child dispatcher. First, root. This is the message sent from the root. I'm not sure whether you have noticed that I do not explain this code before. You can hear here, when the system is started, the root master need to send a message to the register. The root master need to send the peer. The peer need to the root using the peer method to send the message to the register. The register then responds all the IP address of the peer of all the children in the distributed system. So in this response, all the IP address within such a system is returned to the root. Then the root can organize the tree. Then the root can interact with all the children, right? Through the multicasting approach. Here, after the root master is started, the root master broadcasts one notification. This notification called root IP address broadcast notification. Then all the children within the system can obtain the IP address, can obtain this IP address of the root. That's why the IP address need to be returned, right? So IP address of the peer can be obtained through this way, right? This peer is now is a peer on the root. So this IP address is sent to all the children in the distributed system. So here, this notification is used to keep the data from the root. The root IP address is kept here, right? All the IP address. So if the peer get the root IP address, it set it here. It keep it. We just explain this code, right? The IP address is kept. So in the next step, when response need to be collected, the children can send the response through this IP address. And then before that, the child master need to perform a notification. Let us take a look at this code. The child master is implemented with child client. Child client is used to forward its information, its message from its parent, and then forward this message to its directly connected children. So each children, if this children is not, if the children is not the leaf, it need to require to do that. So each children need to perform that. So if the children get the IP address of the root, it need to broadcast, keep broadcasting, right? Keep broadcasting. So through this way, through invoke the async notification. This notification is based on multicasting, not unicasting. It's very similar to the three-tier architecture, right? In the three-tier architecture, if the notification is obtained by the middle tier, then it just forward this message to the third tier, to the terminal. This is the same thing. Okay, it's better to use a synchronous approach, such that this one is not blocking method. So this one is when performing a synchronous multicasting, this method can be executed without can be executed fast enough, because this one is not a blocking method. So it's better to forward the incoming message asynchronously. Okay, let us take a look at this one. This one is also sent from the server, is forwarded by the root. So after this notification is received, the child need to forward, keep forwarding, right? Keep forwarding based on multicasting, not unicasting. This one is just send using using the TCP one-to-one client to the server. However, this one is based on multicasting. And then display the message. This one usually should be performed asynchronously. Okay, what about this one? This anycasting. When a message is received, even if the message is anycasting, just display here. Why? No forwarding is performed. That's because when the child is perform something, do something for unicasting and anycasting, that means because the child, the definition of anycasting is if the message received at least one child, that's enough. The procedure of multicasting is finished. So that's why no any forwarding is performed here. If you like, you can still perform forwarding using the similar approach of this one. You can also do something here, no problem. But I think in term to save computing resources, it's better stop here, right? Then a lot of computer resources can be saved. We do not need to perform multicasting for here because this child, this is one child. At least this child receives such a message, so it's not necessary perform forwarding anymore here. If you like, you can do that. But I think it's better to stop here because we need to save save computing resources, right? This is unicast. Let us take a look at unicast. Yeah, unicast, that means this message is sent to this child only. So this child is not required to perform forwarding. Let us take a look at reading. This is multicasting reading. Multicasting reading. So when the multicast request is received, this request should be forward. Okay, just invoke this method. This one is very easy, right? The child client I just mentioned, child client, the code structure for child client is exactly the same as SRE, the synchronous removed eventer. Even it is called read because there's no any responses, right? This read is actually the same as eventer, right? As the notification, as notify. That's not because there's no any responses. So this code structure is exactly the same as SRE. Okay, let us return here. So perform forwarding this request to its children, and then display this request. Next, because these children need to process after request is generated, you need to process it. This one can be regarded as the process, the code to process the incoming message, and then after it processed, the response should be generated, right? This is the way to generate response. It's no difference from what we have said before. After generated, then this message should be returned to the root. So we can invoke this method to interact with the root, because the root IP address is obtained when the system is started. So the peer can interact with the root. Then we can collect all the responses into the relevant point and finish the reading action based on multicasting. Okay, let us take anycast. This unicast reading, so this message is not need to be forwarded. This response is generated and sent to the server. Okay, sent to the root random point. This unicast reading, unicast request. Okay, displays the message here. No forwarding is required, but the response should be generated. After that, response is sent to the root, the random point. Okay, the last one. Last one is easy to be understood. This is shutdown. In the previous classes, I see I show some demo. I program some system online, but in those cases, because I want to save time, so usually I do not implement such code. But this code is easy. After notification is received, the multicaster this message broadcasting notification. So this message should be forwarded. But in this case, I use synchronous notify. Why? Because we need to ensure if we use a synchronous notify, it's possible for the before it's possible because it's something will happen concurrently. The stop and the notification will be happen concurrently. It's possible that before the notification is forwarded, the local peer is stopped. That's not correct, right? Because maybe notification had not been received by its children, but the local child is stopped. So we need to do something here, step by step, sequential. We do something here sequentially, in a sequential manner. So that's why this notification is not performed asynchronously. In the previous classes, you can see this message is forwarded asynchronously. This message is forwarded asynchronously, right? Asynchronously. However, for this case, you should not forward this message synchronously or asynchronously. You should do that with a blocking method. Okay, so the system can be shut down. Okay, that's the I think I explained all of the code. And there's still code we need to mention. This is the client, but the client is easy. You must have seen similar code before. The most important one is this one. You can see this one is the root. It's CS client. This is not root. This is the CS client. We see such API before. This is the first advanced API I program. It just encapsulate the synchronous remote eventer or synchronous remote eventer and the remote read together. So we can easy to use it. And one difference is that we need to keep the root address. How to get the root address? The peer, when the peer started, it can interact with the register, right? So because the root is a peer, so the IP address of the root is kept on the register server. So according to the name, this is the name. According to the name, the IP address of the root can be obtained by the client. Then the IP address is kept here. So the client can interact with the root. After the message is received by the root, all the message can be multicast. Okay, so the client is easy to be understood. So next, I want to show you the step how to run such a system. I want to run the multicasting framework for you. Okay, let us let us log in the remote server. Log in the remote server. Let me see whether the system is started or not. Okay. Oh my god. Oh, server is done. Okay, let us try again. Okay, server started. Takes so long time. Okay, server started. Let's try access again. Oh. The computing environment of my now I'm not in my lab, so okay, that's great. The computing environment is not good. So let us take a look. This one, multicasting. Okay, you can take a look at this. There are five directory for this demo. Five directory. The first one is admin. Admin used to manage such system, shut down the children, shut down the register server, shut down the root. This is child. All the code for child is here. This is the client. What about this? This is the register. The client sends data to all the children, right? And send the data to the root, and root broadcasts the data to children. This is register service. Oh, because the peer, the root is the peer, the child is the peer. Only the peer-based distributed is scalable. So if you want to design a scalable system, the distributed node usually is a peer. This is root. Okay. I think I just update the code. I'm not sure you remember it or not. On the server side, I upgrade the code. So this time I want to deploy the code again. Okay. And doesn't matter. I think we don't want to save time. We just run this code. The code is same. I just upgrade here. I'm not sure if you remember it or not. Here on the root, because I changed the code a couple of hours ago, so I upgrade the code here for this one. Right? This is the code I just upgraded. Okay. Another one is this one. Okay. So, but it's fine. So, but the running procedure is same. So let's run such a system. You must remember this. You must pay much attention to the order to run such a system. test. First, we need to, the first one to be run is registry. Okay, started. Okay, register started. And next, what should be started next? The order is very important for multicasting. Next, you can see I started 4 terminals here. These 4 because in our case, the more computers are required to simulate that. I started 4 more terminals to simulate the case. Okay, each terminal is a child. This is a child. Let us run the child. Okay, the child is run. Okay, you can see this is a register. So the peer, the child is peer first, right? So the peer, after peer is executed, then it needs to add register on the register server. Then its IP address is obtained because all the terminal actually running in the same machine. So it's necessary for the register server to assign port number carefully to avoid possible conflicts. Okay, let us start another child. Okay, the second one. Okay, this one. The IP address is different, right? IP address is the same, but our port number is different. Okay. Start another child. Okay, 4 children enter such a system. Now let us run this one. This is 5th one. 5 children started. Okay. Next. Okay. Next, we need to start. We use this terminal to start the. This should be the 6th one. Okay. Okay, now we have 6 computers, 6 children in the tree structures, the potential tree structures. Okay, next, let us this is 8. This is the 8th computer. Okay, so next, you must pay much attention to the order, right? We first start the register server, and then we start 6, 8 children. Then what else? Now we need to start the root. The root should be started after all the children started. That's the sequence. Okay, take a look. So after the root is started, then all the children, you can see all the children get the IP address of the root. All the children get the IP address of the root, because the root get all the IP address from the register server first, get all the IP address of the children first from the register server, and then it can perform all multicasting. So its IP address, the root IP address, can be broadcast to all the children. So all the children obtain the IP address of the root, and then it's possible. That's a precondition for the child to send their response to the root, because the root is a unique random point. Okay, the last one. Oh, sorry. The last one is the client. Okay. You can see the client interact with the register server, and then the root IP address can be obtained from this register server, and then there is the menu. The first one is if we select the first option, that means a notification will be broadcasted to all the children. Let us take a look at whether it works or not. If we select this first option, then a message need to tap. We can tap this one, a sequence of X. Oh, sorry. We need to type 1 and select. This is a message we want to send. You can see all the children obtain this message, right? A sequence of X. This one. Let me try again. So, well, oh, the connection. My computer got something wrong. I'm sorry. Oh, the computer got something wrong. The remote server is disconnected. I'm sorry for that. The server is not stable. Sorry. It's connected again. Sorry. Okay. Okay. Let's try again. Okay. The computer just got some problem. Okay, let us send a sequence of D. Okay, everything fine. Try again. A sequence of W. Okay, no problem. Great. Let's take another one. Unique. Unicast. Unicast, that means one. For this case, a child is selected randomly. So let us take a look. A sequence of A. Only one child receives such a message. Okay, this one. For other children, the message is not received. Okay. Any other children cannot receive such a message. Oh, sorry. Q. Something wrong with it. This computing environment is not good. Network has some problems. I'm sorry. Run again. Let us try this one. Okay. Okay, something wrong with it, right? The network has something wrong. I'm sorry. I think that's a problem of the unstable networking because now I'm not in my lab. I'm in a travel, so let us try it again. You can see if I type something, no any response. This network is not good. Okay, maybe next time I will show the demo again, but this demo is should be correct. I try it many times before, but for this time something wrong is with it. So I will show this demo in the next class because this time it's lasts a very long time. So I don't think there's the problem of the code because I run this code many times. Because however, for this time, the network is not stable, so it got something wrong. Okay, I will show this demo next step in the next class. Okay, if you have any questions, just let me know. Thank you so much for you watch this video. Okay, see you next time. Thank you so much.